I have taught you load test, right?
Yes, sir.
So you have not been told before that. I have forgot to mention you about open circuit and short circuit test, right? You have not been told about open circuit, short circuit test. Have you been told? Yes or no? Have you
No,
been?
sir. No, sir.
No, sir.
Okay. Okay. You have been taught transformer in your class.
Yes, sir.
Okay.
Yes.
So I think you know what is a transformer, what is the working of a transformer. Now, transformer, we need to know the efficiency of a transformer. So for finding out the efficiency of a transformer, have you been talked about core loss, copper loss in your class? Yes or no? Please reply.
Yes, sir.
Okay. So now the core loss and copper loss, there are two types of losses in a transformer. One is core loss, another one is copper loss. Now how copper loss happens? Copper loss happens when there is a current which is flowing in the transformer. Then I square R loss is the copper loss of the transformer, and core loss, how this happens? This happens inside the core of the transformer. Now as inside the core of the transformer, the flux is constant inside the core of the transformer. Therefore, how the flux is constant, I hope the basic operation of a transformer you have understood. Now the core loss mainly depends on flux and voltage. Now this flux, voltage and frequency. The core loss depends on flux, voltage and frequency. Now the voltage which is being applied to the transformer remains constant, frequency which is being applied to the transformer remains constant, and the flux inside the transformer remains constant irrespective of what load is connected across the transformer. Therefore the core loss also remain constant inside the transformer. Now this, so therefore core loss sometimes called as constant losses. Now in a transformer we can find out the core loss of a transformer by the help of open circuit test. Now in open circuit test what happens, we make the high voltage side, side open, and on the low voltage side we connect an ammeter, voltmeter and wattmeter in this manner. Now the wattmeter has four terminals, one is M, one is L, one is C and one is V. Now this M and C are internally connected. This L and V will be getting, will be showing in a wattmeter how we can connect this M, L, C and V over here. Now, this is the basic operation of a transformer. In this case, what happens? This one of the sides of the transformer is open circuited, and we apply from the primary. The supply is being applied. We calculate the current. Calculate the current from here. We calculate the voltage from here, and therefore we can calculate. Wait a minute. Give me a second. Therefore, we can find out the core loss of the transformer from the wattmeter that is being connected over here. So this is the basic operation of open circuit test. Now let us go for the experiment. Wait a minute. Minute, Dada. Now, this is the basic operation of a transformer. Now, from here, what we can find out with the help of open circuit test, we can find out the active current and the magnetizing current of the transformer. Now, what is active current? The active current is the current which is flowing in a transformer. You know what is the active current? That is the no load current. In no load current condition, how much current is flowing? That is the active current. And what is magnetizing current? The current which is required for magnetization of the core. That is magnetizing current. And what is the one is no load current? That is I naught. Core loss component of current. That is IE or I mu or whatever it can be. I mu or I E, it is being written. And third one is magnetizing component of current. Now, magnetizing component of current is IM. So how we can find out? This is the, have you studied equivalent circuit of a transformer? Yes or no? Have you studied equivalent circuit of a transformer? Phasor diagram?
Yes, sir.
Phasor diagram you have studied.
Yes, sir.
So therefore,
Yes,
you know there is a no load current. Phasor diagram, there is a no load current. In phasor diagram, you might have seen, if this is the flux direction, if this is the direction of flux, then there the no load current is along this direction. This no load current can be divided into two components. One is the magnetizing component of current, another one is the core loss component of current. Now, what is magnetizing component of current? Now you have a transformer is wounded on a core, right? So that core must be magnetized for the transformer to act. That is, to flux must be generated. So for generation of flux, whatever current is needed, that is called as core loss component of current. Whatever current is needed, that is core loss component of current which is there. So the magnetizing component of current is there. That is, it magnetizes the core so that it can pass on the voltage on the primary to the secondary side of the transformer. That is the magnetizing current that generates the flux in the transformer. And another one is the core loss component of current, that is I mu. That component of current generates the core losses in the transformer. Now this wattmeter gives us the core loss of the transformer. This gives us the core loss. Now core loss can be written as V into I. Whatever current that is there, this voltage, the voltage that is being applied and the current which is there, this is core loss component of current divided by V, that would give us I mu, right? Understood? So V into I mu divided by V gives us I mu. That is the core loss component of current. And this ammeter would be giving us no load current that would be flowing. Why no load current? Because there is no load connected across the secondary of the transformer. So therefore, whatever current is flowing over here, that is the no load current. The core loss which is given by the wattmeter, that is W. Now this core loss divided by the voltage applied gives us the core loss component of current over here. And next one is the magnetizing current. So we will be finding the magnetizing current, which would be root under I naught square total current minus the core loss component of current. So magnetizing current, and there is core loss component of current. Sum of this is I naught, that is the no load current. Therefore, any one need to be found out with the help of I naught. So we can easily find out this one. So this is the basic formula. Now you can see over here, shorted. Okay, let me show you the construction. This is, I don't think you will be able to understand how these are connected. Just understand it is connected. Everything is connected according to the diagram over here. There is a ammeter, wattmeter, and voltmeter. There is a transformer. I am showing how the transformer is connected and all. Wait a minute. So this is a transformer. I have said this is the basic connections which you can see over here. Now this connection, this one you can see over here, this is the transformer. That transformer is the terminals, 4 terminals are over this board over here. This red one is the transformer, and on the board the 4 terminals are there of this transformer. Now you can see the high voltage side is open circuited. There is a voltmeter. This is variac. Variac is supplying the low supply to the transformer. That is 55 volt side is connected with the variac. There is an ammeter. This one is the ammeter. Here is a voltmeter, and this one is the wattmeter, which is giving us the core loss. Which is giving us the core loss of the transformer. Now, as we vary the variac, you see what is happening. See from the video I'm showing. So we are varying the variac. That means we are supplying to the transformer a voltage. Now, as you can see, the secondary is open circuited. This 220 volt. Now here we are getting a voltage. We have a 35 volt. You can see the current is around 0.4, 0.4. The current is around 0.4.
So where it is visible?
You cannot see the, okay, wait a minute. Sorry. I have not shared the full screen. Can you see now? Here you can see a variac.
Yes, sir.
Okay.
Yes.
This variac is being rotated. Now, once the variac is rotated, a voltage is appearing across here. The voltage is being applied on the 55 volt side, and accordingly, our ammeter reading is being given here 0.4 volt, 0.4 ampere. There is a wattmeter reading of 2, that is the core loss. This is 2 watts. Okay. Now this is one of the experiment of a transformer. Now let us see the reading of this. So you can see here. So the primary voltage which was appearing across the transformer, once we rotated variac, there we have appeared as 35 volt. Here we have taken the reading of 45 volt, and we have got a 0.5 ampere current reading. Wattmeter reading is 8 watt, and secondary voltage is 160 volt. What is secondary voltage is not required much over here, but okay, secondary voltage is also calculated. That is on 220 volt side. Now, if we are applying 45 volt, ammeter reading is 0.5 ampere. So this ammeter reading is I naught. This is the I naught current which is there. That is the no load current which is flowing. And this wattmeter reading, from this wattmeter reading, we can find out I mu, that is the no load, sorry, the magnetizing current, the core loss component of current, that can be written as 8 divided by the voltage 45. So that would give us the core loss component of current over here. Now I mu is giving core loss component, I naught is giving the no load current. So we can easily find out what would be the magnetizing component of current over here. So these are the reading. You can see this is the open circuit test. So there is a primary voltage. So primary voltage is 45 volt. Ammeter reading is 0.5 ampere. So wattmeter reading, I have also shown what is wattmeter reading, and secondary voltage reading, that is being shown over here, the secondary voltage reading. So these 3 columns, 1, 2 and 3, 4. These 4 columns are already given in this reading, and you need to find out this active current and magnetizing current. So here there would be a bit of it. This would be I mu. So this I mu is, or here it is IE is written, I mu, or sometimes it is also written as IE. So here you can write it as I mu or IE. So I mu or IE, W naught by V. So from here you need to complete these 2 tables from this table. Understood? Understood?
Yes, sir.
Everyone?
Yes, sir.
Okay.
Yes, sir.
So this is the first table you need to complete for observation, open circuit test. And previously I have taught you load test. These 2 has already been shown, and what you need to write in load test I have already told. Now in open circuit test, what you need to write, you will be completing the table with all the calculations to be shown below. Before conclusions, there is a calculation table for load test. Similarly, not calculation table is not there. There is a calculation part in load test. Similarly, there would be calculation part for open circuit test also. In calculation part for the 2 reading, you will be showing the active current, how you have found out active current for both the reading, and how you have found out the magnetizing current for both the reading. Understood?
Yes, sir.
Okay. Now next is open circuit test. Sorry, short circuit test. Now in short circuit test, what happens? Now in short circuit test, what happens? It is performed on high voltage side of the transformer, and low voltage side is shorted. You can see the low voltage side is shorted, and it is performed, all the components are connected on high voltage side of the transformer. The components are connected in this fashion as shown over here. The voltmeter is connected here. There will be a variac. This would be a variac. Now from this variac, you will be seeing this one. There would be a variac. There will be a voltmeter. There will be an ammeter. There will be a voltmeter, ammeter, and wattmeter. This wattmeter would be giving us the copper loss of the transformer. Why copper loss? Because the secondary is shorted, so maximum current will flow from here, and therefore the wattmeter will be giving us the full load copper loss. That is full load copper loss of the transformer. As the secondary is shorted, therefore the wattmeter will be giving us full load copper loss of the transformer. Now let us see what happens for, wait a minute, short circuit test. Now short circuit test, Danny. You can see in short circuit test, the secondary side, that is a short circuit, is performed on the high voltage side. Therefore, the low voltage side is shorted. So you cannot see over here. I'll show you that the low voltage side, which is 55 volt, that side is shorted over here with the help of wire. And all the components are connected on 220 volt side. From the video, you will be able to see that. So you can see this is rotated. So wait a minute. You can see over here that 55 volt is shorted with the help of a yellow wire. You can see over here. This is a bit hazy, but due to video it is hazy. So therefore you can see over here the 5 volt side is shorted, Now we are rotating and we are getting a voltage of 11 volt, and accordingly we are getting an ammeter reading. You can see the ammeter is showing a high value. Why? Because of the secondary is shorted, so a high current will be flowing, and this is the wattmeter that is being shown over here. Now the reading which you will be getting accordingly is these are the reading for short circuit test. In short circuit test, we have primary current, primary on the primary, how much current is flowing here. On the high voltage side, how much current is flowing. And on low voltage side, how much current is flowing, that is being used, that is being calculated from the ammeter reading. There is applied voltage, how much voltage we have applied on the primary side of the transformer, that is on 55 volt side here on low voltage side of the transformer, or on the on high voltage side of transformer, how much voltage is applied, that is being seen over here. This is being taken as reading from the system whatever we have connected, and there is an wattmeter. That wattmeter would be giving us the reading for both the cases. Now you need to write all these things, only these are there: applied voltage, secondary current, ammeter reading, and wattmeter reading, that is being shown over here. Okay, this you need to write down. There is no calculation for short circuit test and all this thing. Okay, any doubt? Anybody having any doubt?
No, sir.
No, sir.
So you submit 6A and 6B, complete 6A and complete 6B by next week of the class.
Sir, 6B was the load test.
Yeah, load test, I don't know how many have you submitted. Okay, you have submitted, maximum of you have submitted. Okay, for load test, I think in load test everything is given. The load test, wait a minute. Okay, manual is given in load test, so I do not need to upload again the manual. So I'm uploading just the title. In title, you submit all the 6A, open circuit and short.
Hello, Arko sir.
Huh.
Now in this testing, you need to the apparatus table and device under test table also.
That has already been told in last class.
Oh, okay, okay.
You know the apparatus table and device under test in last class I have shown, I think. Let me check. Show me, sir. Yes, device under test and apparatus table was told in last class. Okay. Oh, this is all about open circuit and short circuit test. Only one experiment, one or two experiments is left for you.
Sir,
Yes.
sir, device under test in if there is any correction we have to do also.
No, you do not need to write the for 6A. You do not need to write anything from previous what you have written, device under test or apparatus table. Just write down here what you need to write is, okay, wait a minute. I'm showing one of them, one of you have submitted already. So you have submitted for load test under load test assignment. You have already submitted. Some of the you have not submitted. Those of you who have not submitted, submit it as soon as possible for 6B transformer load test. There, whatever I have said that you will submit. Now in this case, here what you will submit is, I'm saying, so here what we will submit first, title of experiment, second, table for open circuit test, Observation table. Next is observation table for short circuit test, calculation, and fifth one is conclusion. For load test, you have submitted title. For load test, you need to submit title, equipments used, device under test, device under test, and then equipments used. Then observation table for load test, calculation, conclusion. So this is for load test you have submitted, and this is for open circuit and short circuit test you need to submit. Any doubt?
No, sir.
No, sir.
Shomi sir,
Yes.
Shomi sir, please take the attendance.
Okay. Number 1. Student, please respond. Roll number 1 is absent. 2,
Present, sir.
3,
Present, sir.
4,
Present, sir.
5,
Present, sir.
6,
Present, sir.
7,
Present, sir.
8,
Present, sir.
9,
Present, sir.
10,
Present, sir.
11,
Present, sir.
okay, 12, 12, no response. Okay. 13,
Present, sir.
14,
Present, sir.
15,
Present, sir.
16,
Yes, sir.
17,
Yes, sir.
18,
Present, sir.
19,
Present, sir.
20,
Present, sir.
21,
Present, sir.
22,
Present, sir.
23, 23, 24,
Present, sir.
25,
আর 10 মিনিটে বেরোচ্ছি, ক্লাস হচ্ছে।
25, absent. 26,
Present, sir.
27,
Present, sir.
28, 29,
Yes, sir.
30,
Present, sir.
31,
Yes, sir.
32,
Present, sir.
33,
Present, sir.
34,
Present, sir.
35,
Yes, sir.
36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39,
Present, sir. 49.
Sir, roll
Yes.
one. Sir, my
Yeah, roll
mic,
on.
I had to join.
I have taken your attendance. Roll number 1, no?
Yes, sir.
And roll number 28 are here. Are you here? Okay. And then 39. It is in chat box. 28. Then 39 is present. Okay. 40.
Present, sir.
41. 42.
Present, sir.
43.
Present, sir.
44.
Present, sir.
45.
Present, sir.
46. 47.
Present, sir.
48.
Present, sir.
49.
Present, sir.
50.
Yes, sir.
51.
Yes, sir.